Today's topic is the quadratic formula, and you can use the date of May 11th. These are the first couple pages of our notes and the last two. So over the course of this unit, we've discovered many different ways of factoring a quadratic equation. So remember, the roots of our quadratic can be rational, so they can be positive numbers, they can be negative numbers, they can be fractions and decimals. They could also be irrational, which are square root radicals, or imaginary. We're not going to cover imaginary numbers in Algebra 1. That'll be a topic you explore with Algebra 2. We also know that the roots, or the solutions, represent where our parabola will cross the x-axis. The first factoring technique that we learned was the product sum method. This is the easiest method. When we use this system, we want to find two numbers that will multiply to -10 and then also add up to 3. We're probably very good at this method by now, so I'm thinking 5 and 2. The 5 is positive, the 2 is negative. So I'll write it as my two binomial factors, and then I would separate this and set each factor equal to 0. And for the sake of time, I'm just going to shortcut it, but x would be -5, and we would also have x equals 2. So my solution set, or my roots, are at 2 and -5. This method of factoring only works for rational roots, and you'll know when you start to come up with factors for the value of c that when it's not going to work, we need to pick another method, and there are times that it won't work. We also learned the completing the square method. This works for rational and irrationals as well. So when we use this method, we keep the quadratic and linear term on the left, and we push the constant over to the right. But when we do that, we make room so that we can complete the perfect square trinomial. To fill in the blank, on the left, it's half of +2, which is 1, and then 1 squared is still 1. So we're going to add a 1 to both sides. The left side will factor into two identical binomial terms. They're both x plus 1. And the right side is 25. And that's a perfect square. So when I see that, that makes me a little bit happy because I'm going to get a nice whole number. So we're going to square root both sides, leaving us with x plus 1, and it equals positive and -5. To get x alone, we'll subtract 1. And now we're going to separate this into two roots. So the first root will be +5 minus 1, giving us a root at 4, and then -5 minus 1, giving us a root at -6. So my two solutions are -6 and 4. Again, this method will only work for rational and irrational roots. We use the quadratic formula so that we can find all roots of our parabola, whether they're rational, irrational, or imaginary. So over here, the diagram on the far right, because it doesn't cross the x-axis, will have imaginary roots. And again, you'll explore that more in Algebra 2, but just know that the quadratic formula will work for all types of parabolas, not just ones with 2 or 1 real root. This is the quadratic formula. The a, b, and c all come directly from our quadratic equation. We also want to make sure that we watch the signs when we sub in. The b in front here is always -b, and this is always minus 4ac. The value underneath the square root radical, b squared minus 4ac, is called the discriminant. And when you look at the value of the discriminant, we can tell what the nature of the roots will be before we complete the process of factoring. So if you look here at this chart, when the discriminant is greater than 0, so we have some kind of positive number underneath the square root radical, that tells me that when I complete my process, I should have two roots. So I should have a parabola that crosses the x-axis in two locations. If I'm doing the math and the discriminant equals 0, and you'll see it right here, that tells me that I have a parabola that touches the x-axis in one spot. It's a double root, but we'll only see it written once. If the value of the discriminant is less than 0, which is negative, that would tell me that I have imaginary roots because it's not going to cross the x-axis. Again, for this level, you should not get a negative square root. If you do, you have a calculation error because we're not at that level yet. So you should either see positive or 0 as your discriminant. For our first example, we're going to take the quadratic equation. We want to make sure that it's in standard form, and the goal is to try to keep the quadratic term positive. So it is in standard form, and x squared is positive 1. Its coefficient is positive 1. So we're good to go. So a is 1, b is negative 10, and c is 13. We're going to start with our formula. Don't forget to start it with x equals because this will identify our roots. We're going to sub in. So b is negative 10, but it's negative 10. So when we sub it in, it's positive. Underneath the square root radical, they're asking for just b. Make sure you put that b value in parentheses so that when you square it, you're going to get a positive value. Then we have minus. 4 is a constant that's always there. We sub in a, which is 1, and c, which is positive 13. And then in the denominator, it's 2 times a, and again, a is 1. Make sure you show the substitution step. In fact, don't try to shortcut. You want to show me all the work in case there's a mistake. We're going to do a little simplifying. So we have 100, and then this is minus 52 all over 2. As I continue the simplifying process, I can see that the discriminant is 48. Because it's positive, it tells me that I should end up with 2 roots. We're not going to use decimals. A square root radical needs to be simplified. It's an exact answer when you leave it that way. So what you can do on your calculator is start dividing 48 by 4, try by 9, try 16. The bigger square root, perfect square that you can find, the better. So when I do this on my calculator, 48 breaks down into 16 times 3. 16 is the biggest perfect square. And as I simplify that, the square root of 16 is 4. You'll notice the 10 and the 2 just stayed put. Now that we're at this stage, we need to get 2 roots, and we're going to divide. 10 divided by 2 will be 5, and 4 divided by 2 is 2, radical 3. So I'm going to go ahead and separate that. We want to make sure that we divide, but both pieces of the binomial in the numerator must be divided by 2. And just like we said earlier, we do have 2 roots. In example number 2, the quadratic equation is not in standard form, so I'm going to move some things around. I want the negative 6x squared to be positive, so I'm actually going to move that term and the positive 6 over to the right. So my equation will start with 0 equals. Both of these move over, so they turn into their opposite sign, and then negative 8x will remain. A is 6, B is negative 8, and C is negative 6. So let's start again with our quadratic equation. We're going to sub in, so negative 8 for B will be positive 8. Underneath the square root radical, we'll put negative 8 in parentheses, minus 4, and then A is 6, and C is negative 6, and in my denominator, I have 2 times 6. Again, be careful with your signs. I'm going to simplify what's inside. So negative 8 squared is 64. The minus sign I left, and when I multiply 4 times 6 times negative 6, I get negative 144. This will mean when I combine it, it's positive 208. So again, I'm going to have 2 roots when I'm done with the factoring process. Because we have a square root radical, I'm going to start dividing by 4 and by 9 and by 16. The bigger the perfect square, the better. So 16 works, and when I do divide by 16, I get 13. I know 13 is prime, so I know that's as big as I'm going to go. We're going to simplify the square root of 16. Now, when we separate this, it will be 8 divided by 12. This will be a fraction of 2/3, and you're going to leave it as 2/3. Then we're also dividing 4 radical 13 by 12. 4 and 12 will reduce to 1/3, and we'll keep the radical 13. So we'll have 2/3 plus 1/3 radical 13, and 2/3 minus 1/3 radical 13. In example 3, Our quadratic equation is not in standard form. Again, I'm going to move negative x squared and positive 2x to the right so that my quadratic term can be positive. So my equation is going to start with 0 equals. And as I move things, signs change except for the 12, which was the constant, and it was really negative 12. All right, I'm going to start with the substitution process. So this is negative b, sub in b with parentheses so that we don't lose a sign, minus 4, a is 1, c is negative 12, and it's over 2 times 1. Simplify, steady, don't go get too much all at once. So the second part of this term is negative 48, but it's minus negative 48. So that's actually 52. Again, I should have 2 roots when I'm done. I'm going to find 2 factors of 52. When I do that, it looks like 4 is the biggest perfect square, so it's 4 times 13. When I simplify, I will get a 2. This one's nice because 2 divided by 2 is 1. And then for the radical, 2 radical 13 divided by 2 will give me 1 radical 13. So I'm going to have 1 plus radical 13 and 1 minus radical 13. But I do have 2 roots. In number 4, again, we're not in standard form. I'm going to add 2x squared to both sides so that I can get my quadratic term to be positive. So in standard form, we'll have positive 2x squared, and then I move the negative 2x forward, and I push the negative 20 back. So a is 2, b is negative 2, and c is negative 20. We'll go right for our substitution. I'm going to simplify what's underneath the square root radical. Make sure you show me both terms. And again, it's 4 minus negative 160, so that will give me a positive value of positive 164. I should have 2 roots. And 164 is not a perfect square, so I'm going to, again, use my calculator. If I divide by 4, I'm going to get a factor of 61. I think that's 41. We'll change that to 41. And we'll change this to 41. So when we simplify, we have 2 divided by 4, that will be a 1/2. And same thing with the radical. 2 radical 41 divided by 4 will be a 1/2 in the front. So we want to keep it as 1/2 plus 1/2 radical 41 and 1/2 minus 1/2 radical 41. In our final example, this is really an incomplete quadratic equation. We're missing our linear term, which is x to the first power. So I'm going to subtract 18 so that everybody's on the same side. But just so that I don't get confused, I'm adding a linear term of 0 times x. So a is 2, b is 0, and c is negative 8. When we sub in, we actually do sub in the 0 for b. The 0 in the front really isn't serving any purpose. So in the next line, I am going to eliminate it. And same thing here. This will just turn into 0. But I will multiply these values, negative 4 times 2 times negative 8. So it gets simple really quickly. So I have positive and negative, and this will become positive 64 all over 4. And I know 64 is a perfect square. So at this point, I'm going to separate it and set each factor equal to x. So I have 8 over 4, give me a root at 2. And then negative 8 over 4 gives me a root at negative 2. So my solution set will be positive and negative 2. Tonight's homework is number 113. It'll just simply say quadratic formula at the top, but you can see the first 2 problems, so you'll know to pick the right sheet. I'll also attach the sheets digitally. If you have any questions when you're going through the notes or the homework, please contact me. I'm happy to answer your questions. Otherwise, have a great day.